Next we have the law of cosines. Again, we're trying to solve non-right triangles. In this particular case, we do not have a side angle pair like we were looking for in law of sines, and we have no way of finding a side angle pair because we only know one angle in this diagram. In this particular example, we have side, angle, side, which should be your cue to use the law of cosines. This is the law of cosines in its most basic form. Now, obviously, you'd have to apply that to any triangle, say this triangle tin or knit or whatever you want to call it. But the idea here would be that if we're looking for this side here across from angle I, so little I, that would have to be the side that's by itself matched up with the angle. So if I set up the law of cosines, then the 22 and 37, it doesn't matter which one is A and which one's B. So I'll substitute, so I have I squared, and that's going to equal 22 squared plus 37 squared minus 2 times 22 times 37 times the cosine of my angle 61 degrees. Now, because there are no variables here, I should be typing all of that into my calculator at one time. I should not do that in parts, simply because I don't want to make any errors as I'm typing it in. So if I do that correctly, I will get an answer for I squared. Remember, it's I squared that equals this. So I actually get 1063, 73. And then I would want to square root that answer, okay, to get my final answer then, which is side I 32.61. So like I said before on the law of sines video, if you watch that one, anytime I'm solving a triangle completely, it's usually a good idea to list out all my parts so I don't forget anything. So if I do that here, I'm kind of behind. 61 is the angle that I know. I now know, or I knew side N was 37 and side T was 22. I calculated side I to be 3261, and now I have that angle side pair that I spoke about in the law of sines video, which means law of sines would be what I would like to use to continue to solve this triangle for its missing pieces. So the sine of 61 over 32.61 will be the sine of N over 37. Again, I'm going to cross multiply to solve this proportion. The difference here is I'm looking for an angle N, which means I will have to do the inverse sign to get that answer for N. So if I do those calculations, and again, I'm trying not to round, so I'd like to use the answer in the calculator to get the next answer, if that makes sense. And at the end, I'm going to have to do the inverse sign of to get 82.9 degrees. Okay, so that angle there, N, is 82.9. And now that I know two angles to find the third angle, all I would need to do is apply the triangle angle sum theorem that I had talked about again in the previous video to get that third angle. 36.1 degrees.